Alright, let's pick up where we left off and wrap up this exercise 3 on manipulation on strings. We are going to finish with the str extract function. The role of str extract is I give you a string, the first parameter, and I'm giving you two indexes, start and end, and you are going to allocate a new string big enough to contain every character between start and end indexes in S1, and +1 for the mark of end of string. So that's the purpose of str extract. So once again, we allocate memory, we return a new resulting string. Notice that the length we are going to have to allocate is end minus start +1 to account for the \0 character. Notice as well that we return null in a certain number of cases. If the allocation failed, of course. If S1 is null, if you do give me a null string to work with, I cannot extract anything from it, so I return null directly. If end is greater than str length of that string parameter, there is a problem. If end is lesser than start, there is a problem as well. So these are all the conditions that will cause this function to return null. So when you establish a contract like that, of course you rely on the programmer that will use your function to follow that contract. Okay, test the return value and do something about it. So let's start by the declaration. Char star str extract char star s, we're going to call it s simply, int start int end, and this is it for the declaration. Let's go and write the definition of this function. Body of the function will be here, and there we go. So what do we need here? We need first we're going to need to allocate some memory, and we need to measure the size of the string we need to allocate. So let's start by measuring the size. This is going to be end minus start +1 to account for this extra end of string character. So we have here our size. Then we can try to allocate dynamically some memory for this string buffer. Malloc size of char times the size that we just computed. So there goes our memory allocation, and then we're going to start going through all the conditions that lead us to return null. If not p, I already explained how that works, return null. If not s, if my string I'm supposed to work with is actually null, then I return null as well. I don't even work on it. Then the 2-over condition, where if the length of s is actually, let me double check this real quick. If the length of s1 of s, our parameter, is lesser than end, the end index, then that's returning null as well. And we have one possibility left. You could rewrite this really like in a more compact way with a single if statement and a bunch of conditional operators. However, this has the advantage of being extremely readable. Okay, so we are going to go with that for now. I'm going back to the slide real quick. If end is lesser than start, that's it, and lesser than start, then return null as well. So we got rid of the memory allocation. We made sure we were not in a situation where we needed to return null. Okay, and then what we have left to do is to make a copy of everything that is in the string s between index start and end into that newly allocated string. So here's a way to do it. Oops. For I equal start, I'm going to do I lesser equal to end, assuming that the end index is inclusive, but you would have to document that somewhere. So I'm going to have this loop, and inside this loop I'm just assigning to p of index I whatever is contained inside of s index I. Once I'm done, I can say p of I equal \0. I mark the end of my new string, and I can return p. I need, of course, to declare my int index somewhere, and we should be pretty much set. So we have here str extract. We go back inside of the main, and I already prepared some code to test str extract. What I'm doing is right after I concatenate to string into the string p, and before I deallocate it, I'm going to be declaring a pointer x, a star pointer x, extracting inside of this p string, which is equal to I word exclamation mark, 3 exclamation mark. I'm going to extract between index 3 and 7, which correspond to the word word, and I'm going to store that in x, and I'm going to display the string. The extraction of index 3 to 7 inside of string p is equal to the string contained right now inside of x. Okay, so I could have written this a little bit more compact. This is what I'm going to do right now. I'm sparing myself, well actually no, if I do that, same problem than before. You know how they say that best is the enemy of good. If I do that, I'm going to lose my reference on x, and therefore I could not deallocate it here. So I'm going to leave it at that. It's a good solution. I save, switch to the terminal. I'm going to compile. Linkage problem, str length. Well, that's English spelling problem. It's not even linkage. So let's go back where I used str length. I think it was down here. That's one of the big advantage of actually developing small modifications, small function, compiling, testing immediately. If I would develop, I don't know, 300 line of code or modify like 10 different files here and there before to recompile and retest, when a simple problem like that pops up, it can take you a lot of time to figure out exactly where you have been committing this error. So it's compiling right now. I'm executing. Here's what we have. Concatenating high with word results in high word, and we have a little problem here with the extraction. The extraction tells us that the result is an empty string. So let's go back to our source code and let's figure out where this problem comes from. So let's see. We have okay, this is a loop. Copy pi si into pi. The problem with this loop is we have here the start index for I, so we are iterating over s, the string s, using the index I. However, in the string p, which is much smaller, we need to subtract start from I every time, so that we start at 0 while we are iterating between indexes start and end in the string s. So let's compile again, save, and compile again. It compiles right. Execute, and then there we go. We have the string word here that is working. Okay, back to the string, and we are done with the last of those exercises.